So those at the back who are struggling, come on forward, now's your time. But yeah, so our first story for the afternoon comes from Alistair Collo. So we're basically going to be talking about space-time pattern mining. And this really sounds like a sci-fi movie to me, so I'm excited to hear more about it. Please welcome to the stage, Alistair. I should probably put up his slides. Yeah.
Good start.
Be quite helpful. Ta-da!
I wonder. I'm just going to check whether this actually works. Well, now you're all filled with food. I'm going to fill your minds with a bit of knowledge. Don't worry, it sounds complicated. I'm going to walk you through the full process so you get an understanding. So, kia ora everyone. My name's Alistair. Today I'll be talking to you about emerging crime hotspots in Auckland using a tool I developed in ArcGIS Pro as part of my postgraduate studies at Massey University. So let's dive straight in. This is a quick overview of what I'll be covering today. I'll start with an introduction to the importance of this topic. Then I'll explain the space-time pattern mining analysis process in ArcGIS, which includes using Esri's space-time cube and emerging hotspot analysis tools. Following that, I'll talk about the results of the emerging crime hotspots and comparing it to traditional hotspot analysis methods. Finally, I'll conclude with key findings, implications, and some limitations. I will have, obviously, a chance for you to ask questions at the end of the session. So why is it important to analyse crime data? The number of crimes and statistics are not just numbers, they represent the safety and well-being of our communities. Looking at the temporal or time analysis of these statistics, we can see an increasing trend in the number of crimes, especially in retail theft. But how might we allocate resources to reduce these crime rates? And what areas are most likely at risk? To help answer these questions, I have created an emerging crime hotspot tool that used 3 years of crime data, which you can see up here, to identify crime patterns both spatially in space and temporally in time. So I'm going to be using those words a lot. Spatially, space, temporal, time. All this data was obtained from the Police New Zealand data portal, which is free to access. Hotspot analysis, which some of you may be familiar with, only aggregates points spatially. We consider their locations in the X and Y coordinates in a two-dimensional grid, as you can see in the top image. For the emerging hotspot analysis created by Esri, we aggregate spatially and temporally. Conceptually, it is helpful to think of height as a way of visualising temporal dimension, where crimes at the top occur most recently. To aggregate data for space-time pattern mining, a space-time cube is used. You can think of the space-time cube as a three-dimensional grid-like structure. In this example, you can see any crimes which occurred in the same 10 kilometre by 10 kilometre grid in the same month are aggregated together into a bin and counted. In this example, which is just made up, this isn't the actual data, in this example, bins with higher numbers of points are darker and lower numbers of points are lighter. The space-time cube can also be aggregated into hexagonal grids or any two-dimensional polygon layer instead of symmetrical cubes. So you can see that. For the emerging crime hotspot analysis tool, I use statistical area 2 for aggregating the space-time cube instead of squares. Once a space-time cube is created, this is fed into Esri's emerging hotspot analysis tool in ArcGIS. Some key terms to remember when talking about emerging hotspot analysis are the study area, the features, and the surrounding features, also called the neighbourhood. A quick recap on these terms. Each polygon in this data set is called a feature, in purple. Each feature must have an associated numerical value, which in this case, in the analysis I did, is the number of crimes. Every feature has a neighbourhood, which is made up of the surrounding features and the feature itself. The study area includes all of the features in our dataset combined. So feature might be just one part of Auckland, and the study area is the whole Auckland region. Tobler's first line of geography states, we expect things that are near each other to be related. So an important part of emerging hotspot analysis is to determine the distance and time at which we expect the phenomena we are studying to be related. This is called conceptualizing spatial relationships, or defining what it means to be a neighbour. For emerging hotspot analysis, each feature has spatial neighbours, or closest in space, and temporal neighbours, closest in time. So in this example, outwards is going to be your spatial, and downwards is going to be your time. There are several ways of determining neighbourhoods. For the emerging crime hotspot analysis tool I developed, K-nearest neighbours method was used to identify spatial neighbours. This method was chosen as the space-time cube has been aggregated into non-uniform areas, the statistical area 2, and K-nearest neighbours finds the neighbours that are closest spatially and therefore most likely to be related. Temporal neighbours uses fixed distance based on the time period that is selected. In my analysis, I used 3 months. The process of determining exactly how many neighbours to use spatially and temporally is iterative and does require some professional judgment. There's no perfect right answer. The emerging hotspot analysis first checks if a neighbourhood is significantly different to the study area. If it is then identified as a hotspot or a cold spot, depending on whether it is significantly higher or significantly lower than the study area. Bloop. It is only the feature and not the neighbourhood that is highlighted as a hotspot or a cold spot. The emerging hotspot tool then assigns each bin with a probability measuring how likely it is to belong to a non-random cluster of high values, hotspot, or cluster of low values, cold spot. Once all of the features have been analysed, let's see, fills it up, you have a new space-time cube with results shown here. Again, this isn't my actual results, this is just an example. The type and intensity of clustering is then summarised in each location in a two-dimensional grid and categorised based on the location's pattern or trend over time. The emerging hotspot analysis tool defines 16 possible types of significance. Each describes a unique temporal pattern. The key temporal patterns for understanding the emerging crime hotspots tool are new hotspots, which has not been significant previously until it became a hotspot in the most recent time period, intensifying hotspots, which have been hot 90% of the time and there is a significant upwards trend, and sporadic hotspots, which has most recently been hot, but over time has switched between hot and not significant. To undertake space-time pattern mining analysis described so far, you need to run 2 different Esri tools, one for creating the space-time cube and one for running the emerging hotspot analysis. The new emerging crime hotspot tool I developed simplifies the process by merging both tools together into one easy-to-use tool, as well as reducing the number of required inputs. This tool allows you to input crime data points over any time period, select the New Zealand territorial area of interest, and run the full analysis workflow. This is especially useful because of the iterative nature of this kind of analysis. Now let's turn our attention to results. When comparing the emerging hotspot analysis on the right and the hotspot analysis on the left, we do see quite a difference. When we compare what these two results have in common, we see that the hotspot analysis does identify neighbourhood hotspots in the central and south Auckland areas, which is in line with the emerging hotspot analysis results. However, the emerging hotspot analysis provides further detail, identifying areas intensifying or newly emerging hotspots in South Auckland and Central Auckland being an intensifying hotspot. When we consider what the differences in the results are, we can see that the emerging hotspot analysis identifies hotspots in Western and North Auckland that are not identified when only considering crimes spatially in space. For the highlighted areas in the emerging hotspot analysis map, the red areas indicate a run of statistically significant hotspots in the most recent time steps. The lighter red areas are sporadic hotspots, which is what I mentioned earlier. This shows the importance of considering crimes both spatially and temporally. From the emerging hotspot analysis results, we can see consistent and intensifying hotspots in many suburbs, which indicates an increasing number of crimes. It is also noted that there are no persistent hotspots, which indicates that crime spatial dynamics change over time. This is commonly due to crime diffusion or displacement, where crime prevention efforts can cause crimes to move to different areas or to the surrounding suburbs. In conclusion, the emerging crime hotspot tool that I developed provides a valuable tool for understanding and addressing evolving crime patterns. Tools such as this can help with prioritising resources effectively. It is also important to acknowledge the limitations of this kind of analysis. Two key limitations are data quality and temporal trends. The data quality and quantity is important. There is the potential for bias in the results, such as more frequent recordings of crimes in certain areas that can skew the final results. Emerging hotspot analysis also relies on historical data, which may not capture rapidly changing trends. Further research building on this study could include undertaking a regression analysis to identify factors associated with why crime is increasing in certain areas. Further study into crime displacement and diffusion, where crime shifts to new areas or the neighbouring areas, and the effectiveness of long-term crime prevention strategies could also be looked into. At this point, I would just like to say a special thank you to Dr. John Laurie and Rachel Summers, who is actually here in front, who supported me throughout this research project. Thank you for your attention. Happy to take any questions. It was a lot, I know. Yeah, I see one at the back. Yeah, so that's a, this is what you're talking about here. So it's a statistical analysis. I've got it written down here somewhere. Essentially, it looks at the probabilities. So the bell curve that you're seeing is simply a probability curve of how likely it is to actually be a hot spot or a cold spot. Exactly how that works could be a whole presentation in itself. But yes, so it does look at whether it's random or whether it's statistically important or significant. Yeah. I can also, I was told when I did the run through of this presentation that it was a little bit hard to see on the earlier slide, so this is what it actually looks like. A bit closer up, but again at the back you probably can't see it. Any other questions? Oh, Rachel Summers. Go. She's reviewed all my projects and everything, so this should be interesting.
Can you look through temporally the spatial, the time cube, temporal time cube?
Yes, so there is a tool for within ArcGIS for looking at the time cube itself. I personally haven't looked into it, and my understanding is it can be a little bit clunky. I think there is some newer stuff being brought in which allows for easier, Ecotech probably let me know more on this, but I believe there is some more like newer stuff coming through which will make it easier to look at space-time cubes.
That'd be cool, because I'd be interested in why Ringatoto was actually a cooling crime spot.
Exactly, yeah. Also, you've got to remember that, because these are statistical areas, there could be a crime which was located on the water or something, and then the nearest land body was automatically associated with that. So there could be a bit of that going on. In the pink here, yep.
What was your biggest challenge?
Well, two biggest challenges. One was the guidance on exactly how to do this process. Even though it looks very straightforward when I presented it, I had to work from the ground up on exactly how to get the time cube, what all the different inputs were, and then putting it into the emerging hotspot. And it was a lot of iterative process. I think I ran about 50 or 60 runs trying to get the final result. Once I developed the tool, because originally I wasn't going to, it sped up that whole process, and you're just able to quickly change between 1 month, 3 months, 6 months. Same with how many neighbours you're going to have. Is it 5? Is it 10? And it does significantly change the output. If you start increasing the time period, you'll find that it lumps more areas together, so more of it starts having hot spots or cold spots. So it's the fine line. There is no definitive answer. I'm sure if someone else ran exactly the same analysis of me as me, they might say that actually 2 months, not 3 months, is the right answer. So, but in the general scheme of it, this gives you the right idea. It's just essentially another way of seeing information and being able to make some calls, and there's lots more you could do with this data. Yeah. Any other questions? At the back again, yep. Yes, absolutely, yes. So there is an effect if you start going on too small a scale. As your mesh area gets too small, the hotspot analysis might not give you the results that you're quite looking for. I found that statistical area 2 is kind of large enough that you're not getting kind of too much localized issues, particularly when I was discussing around if someone does, if the police reporting is much better in one area than another, it might throw off your results, and that could happen. You could just have one mesh block that has a lot more data points than another. So there is essentially like you don't want to use it on too small a scale sometimes. Yeah. Okay, but feel free to come and talk to me later if you'd like. Yes. Thank you very much.
Cool, yeah, definitely follow up with Alistair later, like yourself, Kim. Thank you so much. In my excitement to hear more about space-time pattern mining, I forgot to give you a run through of what we're actually doing this afternoon, so I'll just touch on that briefly now. I'll just swap across to our